Hi everyone, it's Liana, ELA for Financial Management. I've been asked to do a video showing how we actually calculate present value. So here we go. I've got 3 questions all from Chapter 5 in the e-text. There's the review question 5.2, question 11, and question 35. So hopefully this makes you the understanding of the calculation of present value a lot easier for yourselves as you go through this explanation. I suggest you get a piece of paper and your calculator and you do it along with me. I will prompt you throughout this video to pause and calculate things for yourself. So just a bit about present value. It's basically looking at a dollar value in the future and what it's worth in today's value. So you do that by discounting it backwards. So it's really good to decide to use if you're trying to figure out if an investment is worth it or not. So that's what we're kind of going to do right now. What I've got here over here is our present value formula. So present value equals the cash flow at the end of the period over 1 plus R, which is the rate of return, to the power of number of periods. So in this, all these questions, our periods are years. I've put in a little rule down here. So this is how we calculate. So how many places do we round to? So if we're mid-calculation, we're going to round to 4 decimal places and our answers are going to be rounded to 2 decimal places. Okay. So what I've done is I've laid out our spreadsheets in 2 colors. Our blue is our key information and our calculations is our pink. Sorry, I've got a scratchy throat. So I find that with these wordy questions, it's super helpful to pull the most vital information out. So when you're looking at it, it's a lot more visually appealing. So let's have a read of this question first. Suppose that you have just celebrated your 21st birthday. A rich aunt set up a trust fund for you that will pay you $200,000 when you turn 30. If the relevant discount rate is 8%, how much will this fund be worth today? So we're trying to find out our present value, and this is at 21 years of age. So we know our future value is 200,000. Okay, what is our number of periods? So how many years? 9, because that is 30, when we get it, minus 21 years of age. Okay, our discount rate is 8% as it states above. So that's all the information we need out of that question, these 3 points here. So I'm going to show you very, very detailed here. I'm going to write out every single step so you can really see it. So here, if we look over, this is our formula. So our cash flow at period 1 is 200,000. Divide by 1 plus our rate, which is 0.8%. Okay, and then to the power of how many years? It's 9 years. So that is our formula in full right there. So it's a great idea when you're doing your assessment, if you're doing your report, you're doing your exam, to show everything. Because even if you get your final mark incorrect, there may be part marks we can give you. Okay, so then what's the next step we can kind of do? 1 plus 0.8. So that's our next little step. I just added these 2 together here. So I'm doing this very detailed for this question here. What's our next step? So in your calculator, it should be, sorry, I've put a bracket too early. Actually, no, that's correct. Okay, so our next step is 1.08 to the power of 9. So everyone get their calculators out, pop that in. So remember, we're going to 4 decimal places, so the answer is 1.9990. There we go, we've got 200,000 over 1.9990. What's our answer? It is $100,050.03. That is our answer right there. So what that's saying is the funds we're going to get when we're 30 years old of $200,000 is actually worth in today's money $100,050.03. So that's it. That's all you have to do. I've made it very long here, showing you every single step, but I'll make it a bit simpler in the next one as we go. So let's move to question 11. Oops, sorry, let's bring it to the top. So here is our question up the top. So we've got two scenarios here, and I've just created this table to make it super easy for you guys to calculate. So when you're in the exam, it might be a really great idea to, if you're required to calculate anything like this, to use tables, so it's really clear for yourself, so you can follow through on your own workings when you're working through it, and also for the marker. It's essential in both reports and exams and time worksheets, whatever other forms of assessment, that you're able to show your workings rather than just have an answer with nothing behind it. I'll preach that all day long. So again, we've got the formula of the side here. Before we get stuck into it, let's read the question. Investment A pays $2,000 per year for 3 years. So we've got $2,000 here for investment A, and this is 3 years. Investment B pays $1,600 per year for 4 years. 4 years. Which of these cash flow streams has a higher PV at the discount rate of 10%? And then what happens if the discount rate is 40%? So we've got a discount rate here, 10%. So scenario 1 here, I've put 10% here. Scenario 2 here, I've put 40% here. So what is essential here is this is a cash flow. So it's not $2,000 in 3 years' time, it's $2,000 every single year. So there's no one perfect calculation to bring each single payment down to the present value. So we do a calculation per year, then add it up, and that gives us our PV. So let's get into it. I'm going to, this top line here, this is year 1. So discount rate is 10%. So let's start. We've got $2,000 divided by 1.1. Now, year 1, we don't really need to put it to the power of anything. So let's do our little calculation. There's our answer. Now, remember 4 decimal places, because that's not our final answer. Our final answer is the total PV. So we're on to year 2. $2,000 over 1.1 to the power of 2. We pop that into our calculator. There is our answer. Let's do this for year 3. So 1.1 to the power of 3. Let's pop that in our calculator. There we go. So we've got our 3 years. So what this is doing is year 1, bringing that 200,000 back to year 0, year 2 back to year 0, year 3 back to year 0. To get our total PV at year 0, we go year 1, year 2, year 3. Add them together. There's our total amount. So of that $2,000 invested every year for 3 years, it is worth today's money $4,973.70. All right, let's do that exact same thing for investment B. 1,600 over 1.1. So let's do the formula over 1.1. Bam. Okay, 1,600. This is now year 2 over 1.1 to the power of 2. Let's enter it in. I did my formula correct. Yes, 1.1. So which equals 1,600 over 1.1 to the power of 3. All right, we've also got year 4 here happening. 1,600 over 1.1 to the power of 4. So once you get the hang of it, this isn't too hard. It's quite easy. It's just repetitive. All right, there we go. And we have to now sum it up. 1, 2, 3, 4. There we go. So with investment B, 4 years of getting $1,600, today's money, it's worth $5,071.78. Which one would you prefer? Investment B. All right, so next one we've got is the exact same scenario. We'll bring this down here. And our discount rate is 40%. So what I want you to do now is pause this video, do the calculation, and then see what you get. And then once you're done, unpause it and I'll give you the answers. Okay, so hopefully you've done the calculations now. I have done them earlier for you. It's like a cooking show. And there we go. So here are all our calculations for you at the discount rate of 40%. Here are our answers. Which one would we prefer? We'd prefer investment A with a return of $3,100, well, not a return, sorry, a present value of $3,177.84. That is the one we want. So that's it. That's number 11. It is a lot of work, but it's fairly easy. Okay, question 35. Now again, we're present value again. So we've got two scenarios, but 3 different discount rates. So I've put in the 3 different discount rates they're wanting us to calculate here. We've got our 2 scenarios, investment 1 and investment 2. So let's have a read. You've won the lottery and the lottery officials offer you the choice of the following alternative payouts. Alternative 1, $500,000. After 1 year from now. Second one is $960,000 from 5 years from now. So we've got to do it. So if we've got a discount rate of 0%, 10%, and 15%, which one would we prefer? So let's have a little calculation. Sorry about that. So we're just doing the exact same formula over here. So we've got 500,000 over the discount rate is 0, so it's 1 plus 0, which equals 1. We don't really need to do it to the power of anything because it's 1 year. Remember, 1 times 1 equals 1. Let's actually do that calculation. 500,000 divided by 1. So it's 500,000. That's our answer. Okay, let's show you what the 960 is. Over 1 to the power of 5, because it's 5 years. So let's do the formula. There we go, 960. So we've got 500 and 960 as at today's value. Which one would we want? We want the 960. There we go. So what I want you to do is now pause this video and try and do the calculations at the 10% and the 15%. And then once you've done that, unpause it, and I'm going to go ahead with the calculations now. So now we've got the 500,000 divided by 1.1. And we don't need to power it to anything. Again, it's only 1 year. So 500,000 divided by 1.1. There we go, 454,000. So let's do the 960. 1.1 to the power of 5. Let's do the math. Now, when you guys are doing these calculations, you should be using your financial calculator, probably not Excel. It's just easier visually for me to explain this to you. So 10%, which one do we want? We want the higher one, which is investment 2. Let's do the 15% one. Bring this over so you can see everything. So our 15% one is 500 over 1.15. We don't need to power it to anything. So 500 over 1.15. 434,000. Let's do the 960 over 1.15 to the power of 5, because it's 5 years. Let's do the math. 477,000. Which one do we want? We want investment B. There we go. So once you get the swing of it, it's fairly simple. It's not too complex. It's just figuring out how to actually apply the formula. But there we go. We've been through 3 questions, and I hope that helps. Thank you very much.